My name is George, and I'll be taking you through this second part. So I'll be taking you through the R programming language, and we'll also look at the same thing that my colleague Eben did in SPSS, the same data that he used. I'll use the same data in R, and then um, I'm going to do demonstration. So R is basically codes, right? It is not like the SPSS where you point and click. So if you are not very conversant with that, it might seem confusing. But then I'll try my best to explain as I go on so that if you don't understand anything, just um, raise your hand or type in a text. And I'll try my best to explain for you to understand. So let me just share my screen. All right. I hope you can all see my screen. Please, can you all see my screen?
Yes, please.
All right. So I didn't really introduce myself. So my name is George Cheyajen, and I am also a student at UCC, but then I am also into data science and then data analysis. So I work with the Ghana R user community as a trainer. So I train people in how to use this R programming software. And I'm also part of the elite research and data science team. So I'm part of their data analysis team. And today I am privileged to be with you here to walk you through the basics in data analysis using R programming. So this is purely a demonstration, something. It's not a tutorial. So I don't know, maybe it might confuse you a bit, but then we are all learning. So if you don't understand anything, just ask and then I'll try my possible best to explain it to you. Now, what we are coming to do here is the analysis of late presentation with advanced HIV disease. So I'm sure he's talked a lot about um, the paper, the article, how they collected the data, blah blah blah. So you know a lot about the paper. So I'm not going to go into details on the paper. What I'm going to show you is how to get the data into R and then how to start doing your analysis in R. Now we have two forms. The data that we have, the data that we are going to use right now, they are in two forms. We have the Excel form and then the SPSS format. So as he said, once you collect your data, it is better that you input the raw data in Excel and then import it to whichever statistical tool that you want to use. You can also import the data into SPSS, save it, and then you can still import the SPSS data into R. So I'll show you how to import from Excel and then SPSS, the things that I need to do. But before that, let me just give you a brief introduction about what the R software is. So the R software is a programming language, and it was purposely made for statistics. But now, due to a lot of engagements, its usage has been broadened. So you can use it for a whole lot of stuff other than statistics. And the interesting thing about R is that it is free. So I I saw a message in a chat when someone was saying if the software was paid or something. So I'll tell you the difference between the R program and then the R Studio. What I have open right now is the R Studio. So I'll show you how the original R program GUI looks like. But you wouldn't want to work in that. We recommend that you work in R Studio because R Studio makes your work easier, right? When you are typing and then you are making mistakes, it can prompt you that hey, there's a mistake somewhere. And then the original R program interface doesn't look so pretty like this. Let me put it that way. So I'll show you how the original R program looks like, and then we will come back to. So the original R program, so I think I have 2 or 3 versions. Okay, so this is the original R program. So this is how it looks like. This is how it looks like. And then where you have your cursor blinking, you see I have a red cursor blinking here. This is called your console. So this is where you type code. So whatever that you want to do, you can type it here. But we don't normally use this. So what we use is the R Studio. So the R Studio is called an integrated development environment. So here you can do a lot of stuff. You can type code in a console and then in a script. So what I have here in this left corner, right, on my left, what I have on my left here, this is called a console. And then what I have on my right here, where the cursor is linked, what I have on my left is called a script. And then what I have on my right, where the cursor is blinking, is called a console. So when you want to see something real quick, when you want to type code and see the output real quick, you do it in a console. But then when you want to type code structurally, add comments, you do it in a script. So as I was saying, the interesting thing about R is that it is free. And then the next thing is it has a lot of packages. So when I say packages, it is just a collection of functions. So these functions help you achieve whatever you want to do more easily and more quickly. So let's say you want to calculate the standard deviation, the square root, the mean, the confidence intervals of a data that you've collected. So there's a function in R that can help you do that. So you just call the name of the function, you input the data that you want to perform that action on, and then it will do it for you. So there are packages that contains this collection of functions. And R has more than 20,000 plus packages that are hosted on their website. So their official website is called CRAN, C-R-A-N. That is where you can get the software, and it is free. So you don't have to pay anything, or you don't have to copy any crack. It is free of charge, so you can use it freely. And then it also has some functions that helps in cleaning your data. So you see in Excel, you input your data in Excel, and then once you import it in R, you see that there are certain discrepancies. R has a collection of functions that can help you clean the data to make it look the way you want it to look. And then R also helps you to create publication-ready graphics. So we saw that in the SPSS, the graphics were not very nice to publish, right? So we had to go to GraphPad to make it look nice. But in R, you can do everything here. Publication ready. Once you have your graph, you can just copy and paste it in your documents, and then you are good to go. And then there's something we call reproducible workflow. So sometimes you see that you are performing analysis on several data sets, and then you realize that most of the codes that you are doing, they are repeating. So what you want to do is there's something in R that we call markdown, right? So it's like some kind of a reporting structure where you add text to code. So you can do that, you can follow that format, that structure, and then any data that you have, just follow that structure. If the codes are repeating, you don't need to repeat the codes. All that you need to do is you change the data, and then automatically it will adjust the analysis for whatever thing that you are doing. So you can create a Word document, you can create an HTML document, you can create PowerPoint presentations, you can create a blog, you can create websites, you can create books, you can do a whole lot of stuff. So R is really powerful. Right, so that was just a brief introduction of what R can do. And as I said, we mostly do all these things in R Studio because R Studio makes working with R easier. So what R Studio does is it works on the R engine. So you need to have the R program installed before the R Studio will work for you. So if you don't have R, the R Studio cannot work. So the R Studio works on the R engine. So without wasting much time, I'll just go into what we are doing today. So first, we need to load in some libraries. So sorry, we need to load in some packages. So the packages that I was talking about, which I said they contain functions to do things in R. If you want to load a package, you use this function called library, right? And then you specify the name of the package. So the packages that I want are here. Read Excel. So I want to load this read Excel. So this read Excel is for reading in Excel file. And then I do another one, library read R. So the read R is for reading CSV files. Although we don't have a CSV file, but and then library ggplot2. So ggplot2 is for visualization. So this is for making graphs or plotting graphs. And then we have dplyr, library dplyr. So this one is also for data manipulation. And then there's another one called tidy. So this is also for tidying your data. So the same data manipulation stuff. And then I have library haven. So the haven package is for importing files from SPSS, Stata, and all those other statistical tools. And then we have GT summary. So GT summary is to create publication ready tables. So in R, you can summarize your data and then it will print it in your console for you. But when you want it in a tabular form that you can let's say transport to a Word document or a PDF document, then we can use the GT summary to do that. And then the next one is the flex table. So the flex table, it does something similar to the GT summary. But then the GT summary, you cannot export it to a different document. So the GT summary mostly works with HTML file. So the flex table helps us to export the GT summary output into Word document or a PDF document. So we use flex table. Yes, and then we are good to go. So now all our packages are here. So before you can use the library to load a package, you first need to install the packages. R originally comes with certain packages pre-installed, but then other packages you need to install them manually. So what you need to do is, if you want to install a package, you use this code install.packages, right? And then you put the package name in quotation marks. So let's say I want to install read Excel. When I click enter, so it is giving me an error because I have already loaded the package. So you see, it's telling me one or more of the packages are currently loaded. So it means I have to restart, which I don't need to do. So I already have it, so no need to do that. All right, so I already have the package, so I don't need to do the install of package. But if it is your first time, you just need to do install.packages and then you put the package name. So all these packages, they are not pre-installed, so you need to install them manually. Or you can come here, when you come to the top here, you see tools. Then you click on install packages. To open a window, then you type the name of the package, let's say dplyr. You click on it, and then you click install. So what this will do is it will still type the install.packages like this with a name inside in your console. So that is like the graphical way. And then if you want to code it yourself, you just use the install.package. All right, now as I said, I told you that we have the data here. We have this, which is LPAHD data set. This is the Excel format, and then we also have the I don't have SPSS on my machine, so but I'll show you that we also have it in the SPSS format. So where's the file? Okay, it's in the folder data. Okay, so I have, so the SPSS, the extension is .sav. So this is the format. I don't have the SPSS software, so I cannot open the file with SPSS. But I also show you how to import it in your R studio or in your R environment. So what we are doing here, this R studio that we have open here, it is called our R environment. Now, if I want to import an Excel file, I need to use a function from the read Excel package. It is called read underscore Excel, right? And then what I need to do is I specify the location and then the name of the file. Now, before I do this, let me show you something. So when you open your R Studio, it is open in a directory. So the default directory is your document folder if you are using a Windows. And then if you are using a Mac OS, I think it is root user or something. But I am using Windows, so the default will be my documents folder. But then I have changed it, right? So if I want to know the directory where I am working in, I use this code get wd. So it is telling me that I am in C users, my username, OneDrive, desktop, this folder, data analysis clinic. So it tells me I'm inside this folder. So the folder, I can come to files here. So there's another tab below the console here. And then you see that all the files here. So this is the data analysis clinic folder, right? And all the files here, I can see all the files in that folder here. Now, if I want to change my working directory, I'll just click these three dots, right? It will open something here. I'll click on a folder, or let's say where, so here, this is where my data is. I can click on this data and then I'll click open. Now, you see that it has opened that folder for me here. Still, the data analysis clinic is still my working directory. This, if I want to change it, I'll click on more and then I'll click here set as working directory. So now if I click on get wd, you see that now I'm inside the data folder, right? Okay. And the files that I want, they are inside this data folder. So when I use read Excel, all I need to do is specify the file name. So I put it in quotation marks, and then I want LPAHD underscore data set dot XLSX. So this is the file I want. So when I click enter, you see that it has read in the data for me. So this is the data here. Now, when you use a function to read in the data, it just displays the data for you, and that is all. But we want to use the data. So what do? We need to store the data in a variable. I'm sure Eben talked about what a variable is. So a variable here is, let's say, a container that we use to store an object. So it can be used to store several items. So you can store a single item, you can store several items inside a variable. So here, I want to store my data inside a variable. Otherwise, once this is printed out, that is all. I cannot use it. But this is the data that I want to be using for my analysis. So what do? I have to save it inside a variable so that anytime I want the data, I call that variable and the data is made available for me. So I'll use, let's say, HIV data. And then read Excel. So the same name, LPAHD data set. So the name should match the exact name that you have your data saved as. And then you should also remember to add the extension, the file extension. So because there's an Excel file, the extension is XLSX. So I click run, you see nothing happen. So what I want to do is I will do head HIV data, and then it will show me the first 6 rows. So you see that it's showing me the first 6 rows. Now it is telling me that there are 12 more variables. Now it is showing 1, 2, 3, 4, 5, 6. It's showing 6 variables because that is what will fit in the console at the moment. And then it has hidden the 12 variables. Now, if I want to see the whole data set, there's a function called view. I'll do view and then I call HIV data because I know HIV data contains my data. You see, it will open the data here for me. So you see that it has opened the data here in the script pane. So now here I can see all the variables, right? I can scroll, can see all the variables, all the 12 variables, and then all the rows. Can see all the rows, right? All the 315 rows, right? Now we recognize something here. Okay, so PWD is not used in R. I think PWD is for I think Linux or something. But for R we use getWD. So here you see that I have my data here. So now I see that everything has been imported. But let's look at something here. So let's look at this variable here, this clinical variable. We see that it is NA. So NA means that it is missing. So there are no values recorded there. So the whole clinical variable, there is no value there. So it means we need to do something about it. And then these opportunistic infections. So the opportunistic infection, opportunistic specified other STDs. So these ones, we can do something about it. But then for what we'll do today, we will just remove them because we wouldn't use them in our analysis. So I will just remove them, right? So I'll remove opportunistic specified and then other STDs. All right, so I'll remove, okay, yeah, thank you, TA, for the clarification. So I'll remove the opportunistic specified and then the other STDs, right? I don't really need these variables. And then the clinical variable here, all of them are NAs, all of them are missing. So I just remove them. So here, before we do that, let's check the number of columns or the number of variables I have. So we use this function encall, and then we input our HIV data. So I know that we have 18 variables. So the last two are 17 and then the 18. So the 17th and then the 18 variable, I want to remove them. And then this clinical variable, right, which is NA, here I want to also remove them. So this is what I'll do. Once I remove them and I don't store them in a certain variable, the HIV data will still contain those variables. So I have to remove them and then restore them in another variable so that that variable will contain data that do not have those variables. But then I want to keep my HIV data as it is. I don't want to modify it. So I'll use a different name, right, to store the data that I have modified. So the name that I want to use is HIV DF, right? Okay. But first, let me just show you how to remove those variables. Now, I told you that the dplyr provides certain functions for data manipulation. So one of those functions is called select, right? And then select is used to select variables and also remove variables. And then there's also another function called mutate. So the mutate is used to modify existing variables or add new variables. So here I'm not adding any new variable. I'll just modify one variable. So the one variable that I'm interested in is our response variable or our dependent variable, which is the LPHD status. So the lakes presentation with advanced HIV disease, the status, that is our response variable. So that is what I'm interested in. And in R, you see that in SPSS, the software is able to recognize that, okay, this is a category. This is an ordinal category. This is a nominal category. But in R, you need to code it yourself. So if you want R to recognize your variable as a category, you need to code it as a factor. And then, so the factor is just the normal nominal category. But if you want to recode it as an ordinal category, then you need to make it an ordered factor, right? So you order it. So if you know that your category is an ordered category, then you need to code it as such so that I will know that it is an ordinal category. But here, the no and then the yes for the status is just a normal category, a nominal category. So you just code it as a factor. So what I'll do is I'll use select. So the select, I am removing the variables that I don't want. So the variable that I don't want is clinical. Sorry. The first input inside the select function is the data that you want to work on. So the data is HIV data, and then you bring comma, and then the next is the variables that you want to select or you want to remove. So I want to remove clinical. So I specify clinical, and I bring a negative sign in front. So the negative sign means that I want to remove it. Now, you see that the last two variables, their names are long. I don't want to be typing their names. So you can also represent a variable by its position, right? Now I know that the total amount of variables is 18. So the last two that I want to remove, it means they are 17 and what? 18. So I also do minus 17 and then minus 18. So this will remove clinical, the 17th variable, and then the 18th variable. And then, so let me just run this. So if I run this, now you see that I have 9 more variables, right? But previously it was saying 12 more variables. So it means 3 variables have been removed, right? But here I didn't store it in any variable. So it just prints it out like that. When I call HIV data, I will still see the full data set containing all the variables. And then another interesting thing about DPLYR is that you can pipe functions. So you see that I told you I want to remove variables, and then I also want to modify an existing variable. So I can pipe these functions together so that it will do all those things in one single code. Then I'm good to go. So I want to use the select and then the mutate functions at the same time. So with the mutate, this is how you use it. So mutate, you specify the data, which is HIV data. And then what I'll do is the variable that I want to modify, which is the LPA HD status right here. So here it is the same variable, so I use the same name. So what I want to do is I want to change it to a factor. So I use the factor function and then I specify the same name, LPA HD status. Now you see that there are some characters below the variable name. You see CHR, DBL. So the CHR means character. So in our every text or every name is stored as a character, and then every number is stored as a numerical variable. So the numerical variable, we have 2 types. So all numbers by default, they are stored as a double. So a double is a floating point number, which means it is a decimal number. And then we also have an integer. So an integer is a whole number, whether negative or positive. So this is a double. So here it is storing them as a float numbers or decimal numbers. So all numbers by default are stored as doubles in R. And then all text or all names are stored as characters. Now you see that when I change this to a factor, let's look at what happens. So you see that now the LPAD status is now FCT. So it has now changed from the CHR to FCT. So this means that now this is a category, a factor. So in R, a factor is a categorical variable. So now this is a category. So we have changed this character. So previously it was just a character, like a text or a string. But now we have changed it to a category. So now R recognizes it as a category with 2 levels. So let me show you when I say that R recognizes it as a category. So I can extract. So let me use the select. Okay, let me just use the $sign. So I can select HIV data. I can select a variable from a data frame using the $sign. So I just want to select this. So okay, so the HIV data is still a character. That is why it's not showing me the categories. All right, so now I told you that we can pipe functions together. So we can pipe the select function and then the mutate function using this symbol. So this symbol here, this pipe sign, and then this greater than sign. So or you can also use percentage greater than percentage, right? You can also use this symbol. It is the same thing. So this and then this, they are doing the same thing. It is called a pipe. So what it does is it pipes the left hand side code into the right hand side code. So if I have a code on the left hand side, like so if I have a code behind this pipe, so let's say if I have a code here, select HIV data. So let's say I have a code gender, right? And then I also want to do mutate name equals, let's say true, right? So here what this is doing is that it is sending this out. So when this code will run first, the one on the left hand side will run first, and then the outputs that it provides, it will give it as the first input for this mutate function, and then it continues like that. So when I run this, you see that it has created a new variable called name, and then it has assigned true to it. So I selected gender from the HIV data, and then it added it to this, and then I created name. So that is how the that is how the pipe works. Now I want to show you how to put everything together. So now I want to save the data as HIVDF. So here, this symbol here is an assignment symbol. So we use it to assign an object to a variable. And then I want to do, so I bring my data first. So HIV data. Then I pipe it inside a select function. So select. So it is this that I am removing, clinical. So clinical. And then I'm removing the 17th variable and then the 18th variable. And then I'll pipe the output into the mutate function. Now what I want is LPAHD status. So here I want to change it to a factor. So LPAHD status. All right. So if I press enter and nothing happens, then it means we are good to go. So nothing happened. So it means that when I check, so I can view this one to view HIVDF. So it will open another table for me here. So you see that here, the monthly, the clinical variable is missing. And then the 17th and then the 18th variables, they are also removed. So this HIVDF not contains those variables. So we know that our code worked. All right. Now there's another function that you can also use to check the structure of your data. It is called str. So let's check the structure of our data, HIVDF. So here you see it has printed a lot of things here. So I'll just explain some of them to you. So this table, so the structure or the output of the data is called a table, and then it has 315 rows and then 15 columns. So this is the dimensions. So 315 by 15. And then the PID, this is our first variable, this is a character. And then you've seen that the LPAHD status, you see that now it is a factor. And then we see with 2 levels, no and yes. So now R is recognizing them as categories, which are no and then yes. But when we look at the gender, it is not a category, it is just a character. So it is just female, female. But suppose I have also changed it to a character, or sorry, a category or a vector, then it would also show me that it also has 2 levels, female and male, right? So I just changed this LPAG status. But you can also change, if you want to perform like proper analysis, then you need to change all the characters to factors so that I can perform proper analysis on your data. But then here we will do only descriptive statistics. And then let's say I also do the chi-squared for you, how to do the chi-squared. So the chi-squared doesn't really need categorical variables. Like for you to like specifically code them as categorical variable, it will automatically understand the characters as categories. So you don't need to code them, because before you input the data inside the chi-squared function, you need to convert it to a frequency table. So once you do that, then it knows that they are categories. So you don't need to specifically code them as factors. But for other models, you need to specifically code them into factors so that the model will know that you are dealing with categories. All right. So that is that for the structure. And then we come here, we would like to see some summaries or some descriptive statistics about our data, right? So here also I use the dplyr with a pipe. So the dplyr contains a lot of functions. So you see some of how those functions. So we've seen the select and the mutate. So let's look at some of the other functions. So here, let's say we want to see the number of males and then the females, right? And then we want to see their mean age, and then the standard deviation of the age. So what I'll do is I'll use my HIVDF, right? And then I'll pipe. So I want to group by. So I want to group by. So I want to find the mean of a particular group. So I want to group by gender. Gender, right? And then I'll do summary. Summarize or summary. Summarize. So I'll do summarize. So the summarize is used to calculate some statistics that you want. So what I want is I want the mean age, right? So I'll give it the name mean age, and I'll calculate. So the function to calculate mean or the average is called mean. So mean, and then I'll specify age. Now we realize that there might be missing values in our data. So you specify na.rm equals true inside the mean function. Because if there are missing values, the mean function cannot calculate the average. And then I want the standard deviation. So I'll do stdev age, right? So the standard deviation, the function to calculate standard is called SD. So SD, the same age, and then na.rm equals true. So if there are missing numbers, I want to remove them before I calculate the standard deviation. And then lastly, I want number, or let's say count. So the count, you just do this n and then put it into brackets. So when I run this, you see that it has grouped my data. So I have gender, I have female, male. It has grouped the gender category or the gender character. So I have female, male. And then the mean age for the female is 48.3. And then the mean age for the male is 51.7. And then the standard deviation of the age for the females is 10.8, for the male is 11. And then a count. So it means you have more females than males. So it means that more females are diagnosed with HIV than males. I don't know. This is just speculation. So we have more females, which is 270, and then we have males to be 45. So this is just a simple summary statistic that you can do on your data. Now you saw that in the article. I don't know where this is. The article, where is this article? Oh, let me just. So in the article, there was a table that there was a table. I'm just looking. The table that had some, okay, so there's this table, frequency and then percent, right? So we can also create this. We can do this in R. I can create a nice table like this in R. So what you need is called the package you need to do this is called GT summary. So the GT summary has a function that can help you do that. So what you do is you select the variables. So we saw that mostly those variables were categorical variable. So you select the variables that you are interested in, and then you give it to the function, and then it will create the data nicely, right? But I will modify mine a bit. So I will group them by the LPAHD status, right? But before that, I'll just show you that summary data, and then I'll group them. So you can even add a p-value, right? So it can do, because it is a categorical variable, it can do some statistical analysis comparing it to the response variable, and it can give you its p-value. So you can add that. But let's just see the simple one. So yeah, so the GT summary. So I have my HIV data, so HIV DF, and then I select the functions, the variables that I'm interested in. So I'm interested in LPAHD status. I'm interested in gender. I'm interested in age group. I'm interested in marital status. I'm interested in education level. I'm interested in HIV. I'm interested in what other names are there? The variable names. Okay, marital status, monthly income. Okay, opportunistic infection. I'm interested in opportunistic infection. And then I'm interested in, is it residence? There's residence, right? Okay, I think these variables are enough. So I want to create a summary statistic table for this. So what I'll do is all these variables, I'll pipe them inside this function called TBL summary, right? TBL summary. So I'll pipe this and then I'll press enter. So it will take some time to create the summaries because the variables are a bit plenty. So it will create the summary and then it will show me the output. So yes, I can see the output here. So you see that it is showing me, so characteristics. So N is 315. So it means the number of observations or the number of rows. And then we have the LPAHD status The status, this means that it is looking at only the yes. So the yes, I have 90 yeses. And then here the gender, I have 270, 450. And then age group, you can see that. So you see that it has created a nice table for us. So this is an HTML format, right? This is an HTML table. So if you want to export it into a Word document, that is where the flex table comes in. So I'll do that later on. But then let me also, now you see that because I chose the LPHD first, right? It is using one level as the base. So it is not showing the negative ones or the no ones. So now, but now I want to see the no and then the yes. So what I'll do is the same code here, I'll do by, right? So by equals to LPA HD status. Now, if I do this, let's see how the table changes. So yeah, it takes some time, but it will come. So when I did the by, see that now the table has changed. So it has grouped by the LPHD status. So the no is 225, the yes is 90, right? So I have, so for the no, the females, it has grouped the females and then the males for the yes and no. So like that. So you see that for the marital status, so you see it has also created a table nicely for us like this, right? So you can do it this way. So I can also add the p-value. So I can pipe it. So I will do add p. So the add p will perform sometimes. So this will also take some time. So when I do the add p, it will add p-values. So what it is doing behind the scene is it is comparing each category to the by. So it is comparing each category to the LPAHD status, right? So it compares it using, so it will tell us which kind of statistic that it did. And then it will compare those two and then give us the p-value. So let's see what this will also give us. So you see that, yes, so you see that it has put some small 2 here and it will describe that in the footnote. So the 2 is a Pearson chi-square test. So it is telling me that the type of analysis that I did is a chi-square. So obviously it will do a chi-square because these are all categorical variables, right? And then the p-values. So we see that age group is significant. HIV is also significant. So it means age group and HIV are related to the LPAHD status. So you can add p-values like this. But then if you just want the count, right? So here I just want the count, right? I just want the count. So I'll use the TBL summary and then I'll give it a name. So I'll give it table 1. Oh, let me increase the font size. Okay, so I'll give it table 1 and I'll assign it. Okay, so I've assigned it to table 1. It is still working though. But then I've assigned it to table 1. So when I call table 1, see that it will show me the count with their percentages. So now, as I said, you cannot export this the table summary directly. So what I'll do is I use the flex table. So the flex table, there's a function called as flex table. So as flex table, it is the same. So it will just change it to a flex table. So I'll put the table 1 inside, and then you see that it will just change the appearance slightly, but then you see how it has done it. So it has changed the appearance slightly. So this one, I can then, so once I have this flex table, I can then save as docs, right? So I save as and I specify the path. So the path is just the name that you want to save it. So let's say I want to save it as summary stats. Okay, let me just save it as summary dot docs, right? Summary dot docs. So you need to specify the output format also. Because I want a docs, I specify summary dot docs. So I'll just run this. And then it will save it so it will save the file in my current working directory. When I open the files, you see that I have summary dot docs. So let me open it so that we see what is inside. So I'll open it. And then we see that, you see, it has created a table for us here. So this is the table, right? So you can do some editing. If you like it like this, fine. But you can do some editing and then make it look the way you want it to look, right? You can do some editing and make it look, but this is what we have. So this is the table that we just did in R. So the flex table works for all table. So let's see this summary that I just did for the gender, the mean age, and the standard deviation. So if you want to view previous code in your console, just press the up arrow on your keyboard. So you press the up arrow. I want this. So this, I just pipe it into flex table. So if I don't want the output like this in my console, I can pipe it into a flex table and then it will create a table with this. So you see that it has created a table with this. So this table here, I can also export it to a Word document like that. So the flex table, you can add a caption, you can change these variable names, and then you can change the decimal places, right, for these numbers. So you can do all that, but because we don't have much time, I'm just showing you how you can create a table and then export it into a Word document. All right. And then the next thing, so we've seen how we can perform the summary. Then the next thing is to calculate the prevalence. So the prevalence, so it's just the proportion. So the prevalence is like the proportion of the yeses, right, in the PAHD status. So so here too, I did the same summary. So I gave it a name called prevalence. So and then I am using this HIV data, HIVDF. So the count will count the status, the number of statuses that I have. So I want to count LPAHD status. So I just want to show you how it looks like. Okay, let me just remove the assignment, show you the output before I add the assignment, so that you see what is actually happening. Okay, so you see that this is what the count does. So LPAHD status, no yes, so it has counted. So no is 225, yes is 90. Now I want to plot a bar chart, just like we did in the graph pad. And then I want to add labels. So I need to add certain things to this, right? So what I will do is I want to add another column called percent, right? I want to add another column called percent. So I'll add another column called label. So the label that I want to put on top of each bar, I'll also add that. So what I'll do is this. So I'll do mutate. So the mutate, I told you, you can use it to add variables or modify existing variables. So now here I am adding new variable. So the new one I want to add is the percent. So I just want to find the percentage of this, which is just the n divided by sum. And So the n is this, the variable here. So this is just a formula. So it is like the number divided by the total. So because I am doing a percentage, then I'll multiply it by 100, right? And then the next one is the label. So I'm creating a percent variable and then a label variable. So the label, what I want to do is, I want to use that percent, the same percent number, but then I want to add a percentage symbol to it. So what I'll do is paste. So I'll use paste. The paste is to add together characters or variables. But I want to do, okay, let me use the paste because the paste 0 doesn't leave any space. So the first item is the n. So the n, no, so I have the paste, I want to paste, okay, I want to paste n. So I want to paste this together with the percentage. So I want to paste n, and then I want to bring a bracket sign, and then I want to put the percent, right? So I am rounding it to okay, let me round it to 1 decimal place. I'm rounding it to 1 decimal place. Then I want to add the percent, okay, the percent symbol. Percent symbol. And then this bracket. So let me make it page 0. Otherwise, it will leave a space between the percent and then the number. So I'll do page 0. So the page 0 here means that I don't want any spaces between them. So I can specify my own space like this. So I want a space here. But for this, I don't want any space here. Okay, it might look a bit confusing, but then I think people. All right, so let me run this. I think my brackets are not matching. So it means I don't need paste.
Mr. George,
Yes.
you see after the paste
Hmm.
is 0.
Hmm.
There is that you wanted to close some bracket, you put it in column. I don't know whether that one is
So
right. I
this
don't know.
one, this one, this.
This one. No, not that
Okay.
one. No,
Which
not
one?
that one.
This,
Yes,
this.
yes.
Okay.
Yes,
So
please.
this is actually a bracket sign that I want to add.
Oh, okay, okay,
So it is not part of the bracket.
okay. Thank you.
So I think it is confusing it to be a round percent. Okay, let me do this. Yes. So this is what I want to do, right? So this is the label that I want to add on top of the bar chart. And this is the percent values, and this is the count, right? So I can use this to create a bar chart as we saw in the graph part. So what I want to do is I'll use my ggplot. So I told you that the ggplot2 package is for creating visualizations. So I'll create, and then you create the visualizations in layers. So I'll do it step by step so that you see at whatever stage what is happening. So I'll first start with the ggplot function. So ggplot, and the data I want is this prevalence. So I didn't assign it to any name. So let me give it a name, prevalence. right? So now when I call prevalence, it will give me this table, right? All right. So ggplot. Let me clear the screen. It seems ggplot. So data is the prevalence, and then I specify my mappings. So I specify the x and then the y-axis values here. So x will be the categories. So x will be the LPAHD status, and then my y will be so it could be either the n or the percent. So if I want the y-axis to be in the percent, so let me use the percent. So now if I just do this and I press enter, you see that it will create a canvas, right? It will create a canvas with the percent and then the LPAHD status. But I haven't specified any type of plot. So it has only created a canvas for me. Now the next layer that I want to add is a bar chart. So what I do is I bring plus and I'll do geom call. So the geom column or geom call is used to draw a bar chart. So there's another function called geom bar, which also draws a bar chart. But due to the way our data is, so I cannot explain into more detail, but due to the way our data is, that's why I'm using geom call. So geom call. So when I specify geom call, now I want to, okay, let me just specify this and then you see what will happen. So when I do geom call, so you see that I have no and then yes, right? I have no and then yes. They are all the same color, but then I don't want them to be the same color. What I can do is I can specify AES inside this and I'll do fill. So the fill color, I want to use the percent status. So I want to use the LPAHD status. So I'll do LPAHD status. So this is what I want to fill. This is the color. So it will use inbuilt colors to do this. So when I click on right, so you see that it has colored the bars and then it has created a legend. But then we don't need this legend because we know the yes and no, they are already here. So we don't need this legend. So I will remove the legend. Here, I'll do show dot legend. And then I'll just type false because I don't want to see the legend. Right? I'll just type false. So when I run this, you see that the legend will disappear. So there's no more legend. And then I have my bars like this. All right. Now I have my bars, I have them colored. The colors, we can change them, but before we change the colors, let's look at something else. So now I want to add the labels, right? I want to add the labels. So I have this, I bring plus, and then I use geom text. So geom text. This is what we use to add labels in our data. So I specify AES. So inside the AES, I specify label equals. So the label that I want to use is the label, right? The label in my data. So I specify label equals label. And then vertical justification. I want to justify this. So v just the position. So let's not adjust the position now. Let's just see how this will look. Sorry, I didn't. This is AES, not EAS. AES. So it will add the labels. So you see that it has added the labels, but now see where they are at. So we don't want it here, right? We don't want it interfering with the bars. That is why we do the vertical adjustment. So V just equals negative 0.5. We'll just put it slightly above the bars, right? So if I do this, you see that now they are slightly above the bars. But now here, we see that the 225 is also not showing all. So some of the numbers are missing because the graph, the y-axis, the limit is around 75. right? So we can increase the limit of the y-axis, right? We can increase the limit of the y-axis so that we can get more space for this to show. So what I'll do is I'll do plus, and I'll do y-lim. So the y-lim is to specify the limits of the y-axis. So it is between 0, let me do it 0 and then 80, right? And let's see if all of it. So 0 and 80 here, we see that now everything is fitting here, right? Everything is fitting here. So now I have my bars and then I have my labels on top. Just like the same thing that we had here, same. So just like as we have here. So I have my bars, then this. So we can also, so the with the titles, let me add a title. So I can add title using the labs function. So labs, and I'll specify, let me use it. Let me see the title I use here. Okay. So the x-axis is the same LPAG status. So x equals, you put it in quotation, LPAHD status. And then y equals frequency. So I think it was frequency and then percentage into brackets. Something like this. Yeah. And then we can give it a main title, but then I won't give it a main title. So I'll just I just change the y-axis labels and then the x-axis label. So you see that I have frequency and then LPAG status. Okay. I can also change the theme so that I have a tick line for the y-axis and then a tick line for the x-axis. So to do that, I use theme classic. So this theme classic will do that for me. So you see that I don't know, sometimes it takes some time to show. So you see that the theme classic, I have this line, and I have my bars here. So I can also adjust the bar width, right? I can adjust if these bars, I see them to be too big, I can adjust their width. So inside the jump call function, right? Inside the jump call, I can specify width. So width equals, let's say 0.8. Let's see how it looks. So 0.8, you see that this and this. So you see that the width has reduced. So let's say we want this. This is the width we want. So here we have a plot. So if you want to export it, you can click on the export, save as image, right? So when you come here, you can adjust the size, and then you save it. Or you can just copy. You can just copy. If you have a Word document, right? If you have a Word document, you can just come into your Word document, right? Come into your Word document. And then you click Control V. You just paste the picture, right? So this is too big. I don't know. I think I should have made it. All right. So you can paste the picture here like this. And then you have your graph in your work like this very nicely, right? So as I said, um, you can change the color, right? You can change the colors manually. So I can add plus scale fill manual. So the scale fill manual means you want to specify the fill manually, the color of the fill manually. And then what you specify is values. So because here I have only 2 bars, so I can specify C. So I put the color, let's say orange. And then this one, let's say violet. So when I do this, you see that it will change the colors to orange and then violet. Now, there are a lot of colors that you can use, right? if you want to see all the colors, the names, the color names that you can use, you just type colors like this. And so you see all the color names. So there are about 657 color names that you can use. So white, antique white, Alice blue, antique white one, but blanche, almond, all those cadet, cyan, corn, khaki, tomato, coral, all those colors, the names, you can use them to change the color to let's say fit the color that you want. So this is how you can do. So you've seen how we can do a plot, and then we've seen how we can create a summary. So the next thing that I would like to show you is the chi-squared test, right? So when you want to do a chi-squared test, the function you use is chi-scale.test. So this is the function you need to use. And then the input for this function is a data frame in a tabular form, right? You need to put your data in a tabular form. So, and the chi-square is used to analyze categorical variables, and then it can be used to analyze only two categorical variables, right? So the first variable you specify, and then the second variable, they should all be categories, but they should be in a tabular form. So here, I want to perform the chi-squared on several characters, right? So let's say I want so the variable we are interested in is this LPAHD AHD status. So the data is here HIV DF dollar. So, okay, so this LPAHD status, right? So this variable is what we are interested in. So I want to compare it to, let's say, which variable? So I want to compare it to the HIV variable, right? So I use the table function. So table, so this will create a frequency table for me. So HIV-DF dollar HIV. Okay. Yeah, so you see that it has created a frequency table for me. So for no, the stage 1 is 150, stage 2 is 75, stage 3 is 0, stage 4 is 0. And then for yes, 0, 0, 80, 10. So this is a frequency table. It has stabilized it. So this is what the chi-squared function wants so that it can do its analysis. You cannot input the variables directly inside. You need to create a table like this, and then you give it to the chi-squared function, and then it will perform your analysis for you. So now I have this. So let me give this var to analyze. So I'm giving it a name. So var to analyze. So you shouldn't leave a space in your variable names. So var to analyze, and then if I call var to analyze, I see this table. So I use a chi-scale test. So I specify var to analyze. And then when I run it, you see that Pearson's chi-square test. So I have p-value, and then I have degrees of freedom. I have the chi-square statistic. So here we see that the p-value is very, very small. So here we can see that there's a relationship between the LPAHD status and then the HIV stage. So there's clearly a relationship because our p-value is very small. So this is a test of independence or test of association. So the null hypothesis, so this is the hypothesis test. The null hypothesis is that the data, the two variables, they are not related, or they are independent of each. They are independent of each other. And then the alternative hypothesis is that they are not independent, or they are dependent on each other. So this is telling us that we can reject the null hypothesis. So this is telling us that the variables are actually associated or related, or they are dependent on each other. So this is what. So to make my work easier, because I'll be performing a chi-squared on several variables and comparing it to the LPHD. What I did is I created a function. So in R, if you see that you are repeating codes frequently, right, you can create a function so that whenever you want to use that code, you just use the function. So here, the function I created is called chi test, right? And then when you want to create a function, use the function keyword. So function, and then what I want is the variable name or the variable, let me just, okay, var name. So the variable that I want to compare with. So I have my original variable because all the time this LPAZ status, I am using it, but this, the second variable is what I am changing. So the second variable is what I want to input in my function. And then I bring these curly brackets. So these curly brackets will contain the codes that will actually run the function. So the first thing I need to do is the table. So you see that I need a table. I need to convert the variables into a tabular form to feed it to the chi-square test. So the first thing I want to do is to create the table from my variable to HIVDF dollar LPAG status, and then HIVDF. Now I am not using the dollar sign because the variable, this variable name hasn't been specified yet, right? So I use two square brackets to var name. So it does the two square brackets and the dollar sign, it does the same thing. But then when you use the dollar sign, it means the variable has already been declared. So you know that that variable exists, right? But here we don't know whether that variable exists. That's why I'm using the two square brackets. And then I'll come to the next line. So the next line is where the test will happen. So test, so as chi squared or test. So this is the table that I'll put inside. And then I want to create a data frame. So a data frame is just like the data that we imported into our environment from the Excel. So you can do that in R using a function called data.frame. So you can type all your data in R, but then it is not very it's not advisable. It is better that you type it in Excel and then import it rather than typing everything in R. So I have variable. So the variable that I'm testing equals var name. So I'm creating a data frame with a chi-squared test. So round test dollar statistic. Statistic. So two. And I want the degrees of freedom. So deck free. So deck free is the degrees of freedom. So test dollar parameter. So the parameter will give you the degrees of freedom. And then finally the p-value. So the p-value will be, so I'll round it to 4 decimal places. So test dollar p dot value. So I'll round it to 4 decimal. So now my function is complete. So by default, it will return the data frame, right? So when I run this, now I've created my function. So the function name is chi. This is the function name, chi test. So I just specify the variable name. So let's say I want to do which variable? Let's say I want to do marital status. So marital status. Marital status is not found. So names HIVDF. There's marital status here. Oh, I didn't spell it well. Okay, so let me just check something quickly. Marital status is there, so I don't know why. Okay, let me just check my function again. Child test. Okay, my function takes in this table HIVDF. HIVDF. Yeah, it should work. So I don't know why. Okay. So I think I know what is wrong. So I need to put this in quotation marks. So once I put this in quotation marks, you see that it will do the test and then it will create some form of a data frame. So you see that it has created a data frame. This is just one variable, right? Now I want to apply it to several variables. I want to apply it to several variables. So I want to apply it to these variables. So I selected some variables here. Right? I don't want to be typing them all over again. So Control V. So categorical variables. So these are the variables that I want to apply them to. Gender, age group, marital status, educational level, residence, employment status, HIV. Now, what I can do is there's a function called lapply, right? So the lapply, you can apply a function to a list of items. So if I do lapply, so the first thing is the variables. So categorical variables, and then the function that I want to use, child test. So it will create a list. You see that it has created a list. So it has done this and it has created a list. Now, if I want to change this list into something that I can put in a table, I can pipe this inside a function called bind rows. Right, bind rows. So when I bind rows, you see this, it has created this for me. Now, I don't want to see this x squared 1, x squared 2. So what I'll do is I'll change it into what we call a table. So Control Shift M, I'll change it to table as table. Then it will remove these things. Now you see that I have this table for me. So it has done the chi-square test. So this is the test statistic. This is the degrees of freedom, and these are the p-values, right? So I can use the flex table. So I can pipe this inside the flex table, and then it will create a nice table for me, right? So I have this, the chi-square test for all these things in a nice table, and then I can export it into a Word document, right? I can export it into a Word document. So this is just a simple demonstration of how you can analyze data in R. So I know that most of you are not familiar with this, and then a lot of them might sound confusing, but I hope that you have at least learned that there's a software called R, and that you can use it to do your analysis, and then you can use it to plot beautiful graphs. So I also had to do some bonus graphs. So just to show you a few. So I also made a graph like this. So proportion of this by age group. So you can also do a graph like this. And then I also did another graph, which is also a bar chart. So here also, so I did a graph of the LPAZ status by HIV stage. So we can see that the no is basically for stage 1 and stage 2. And then the yes is for stage 3 and then stage 4. So we can also do this. So these are just bonus graphs that I did to demonstrate that you see that these graphs are perfectly publication ready. So just export and then paste it in your documents, and then you are good to go. Yes, so that will be all for my side. That will be all from my side. If anybody has any question or anything that you want to know, I know that some of you are confused, but this is purely for demonstration. If you want to learn more, so you can reach out to us at Elite um, Research and Data Science Institute, and then we can take you through our introductory courses so that you can get familiar with some of these things. So yes, that is all. So if you have anything that you want to ask, I don't know. Anybody has any question or anything?
Sir George,
Yeah, hello.
please, if you want to join the elite Disney, what are the things involved? Elite
Oh,
research.
if you want to join the Elite Research and Data Science, I
Yeah.
think you can reach out to the admins, right? On
Okay.
the page. You see the so you reach out to them, you can talk to them, and then they'll give you the guidelines and then the steps. But we mostly organize webinars. Those ones they are paid webinars.
Okay.
So we teach some of these things there. So
Okay.
you can reach out to the admins on the WhatsApp page, and then you can talk to them.
Okay.
Yeah, Sewa Frimpong.
Okay, thank you so much, Sir George. Thank you so much, Sir Aben. You've done a fantastic job. But like you said, the art studio looks very beautiful and it looks very it's like a proactive coding language. So what I wanted to find out is what my colleague just asked. I wanted to find out in case you want to be part of the ERDRSI, what is the process? He said the admins, can you share the administrators, their numbers? And also I'll request that you do another free session again like this, maybe in the middle, in the course of the month, so that we can join and get more in-depth knowledge about what you just did, both you and Sir Aben, so that we can really connect before we even sign up to the one that we will pay. So thank you so much. It was so insightful and I really enjoyed every session from both you and Sir Aben.
Okay, so thank you very much. For the joining of the ERDSI. So as I said, joining is not really a problem. So joining is not really a problem. Just send us a text. I don't know if you are part of the WhatsApp group page. If you are not, you can reach out to me. So Sewa, I know Sewa personally, so you can reach out to me, and then I'll guide you. And then with the free webinars, yeah, we organize free webinars a lot. Maybe you don't hear about them, but we do organize free webinars a lot. So most of us we are also students. So I am a PhD student, and then Eben is also a PhD student. So sometimes we are very busy, and then we cannot always be doing these webinars all the time. So you can just contact us if you need any help. But then we do have um, times that we allocate to do some of these webinars. So we do organize free webinars. And then someone is asking, how do you analyze open-ended data? So when you say open-ended, like, can you explain? Comfort, when you say open-ended. So our contacts are in the WhatsApp group, right? It's in the WhatsApp group, so you can, and then it's also on the, I don't know if it's on the flyer that we shared, but ERDSI contacts, I think it's on the flyer that we shared. But you can also reach out to us on the WhatsApp page. So please, Comfort, if you can explain what you mean by the open-ended data, then I will know So I think all questionnaires are mostly qualitative or interview form. So what you need to do is make sure that, so the questions that you ask, right, the questions will become your variable. So when you are coding them, so I think there are some um, tools that you can use to code them. They're like the Kobo Collect or something. So once you have your questionnaires, know that the questions that you're asking, the questions become your variables. And then the responses that you get, those responses become your rules or your observations. So you see that when I use the structure on a data frame, I had 315 rows and then 15 column. So the 315 rows actually is the number of responses that we got from the questionnaire. And then the variables are the questions that we asked, right? So we can ask your name. So your name, then name, if we ask your age, then age becomes a variable. If we ask whether you are pregnant or not, that one becomes a variable. So all the questions becomes your variable. So make sure that you are not asking a lot of questions, but then make sure you are getting a lot of response so that your analysis will be reliable. So if you ask a lot of questions and then you are getting like, you have like 20 variables and then you have like 20 responses, then it might not be really reliable. So make sure that you have a lot of response as compared to the number of questions that you have. So if you have different responses, so let's say some of them you have, let's say options. So if you did this, then maybe do that. So the Kobo Collect can reorganize those ones into, we call them dummy variables, right? So if let's say a person selected, so let's say you want to do a sub question. So if you are pregnant, where do you attend hospital, blah blah blah. So those ones you can do something called dummy variable and then replace them with 0 and 1. So you create a whole new column for those areas. So if the person didn't take pregnant, then that will be 0. But if the person take pregnant, then that will be 1. And then you assign what they answered to those ones. And then the ones that were 0, you just leave them. So they are, so those are the things that you can do in Excel, right? Or the Kobo Collect. But then when it comes to actual data cleaning, because sometimes even typo, for instance, for the male and female categories, you see that you might type female with capital F and then female with small f. Now, when you come to R, I would think that the female with capital F and then the female with small f, they are different values, right? So that is when you can do the data cleaning, data manipulation in R. So when you realize that there are some discrepancies in your data, after everything you've done in Excel, when you import, and then you realize that there are some discrepancies, or maybe you might even want to just change the shape of the data, right? That is when you use the data cleaning and the data transformation. So I hope it is clear.
Okay.
So if anybody also has anything, otherwise I'll just hand over to my colleague Eben to give you what he has for us. So I'm sure we have an upcoming webinar. That one, it is not free. So he will talk about that also. And then,
Okay.
yeah.
Yes. So thank you very much for the great presentation, George. And to add to what Comfort asked, so Comfort, if you are into those pure qualitative studies, you can also look for IVUVO. They are for those that only pure qualitative studies and rest without having uniform data to analyze, and we are good to go. So thank you very much for the great presentation, and we are very happy for the journey so far and more than 4 hours on joining us to this stage. So first, I'm going to stop the recording.